Notes 12.2 and or and not in logic. A compound statement. So a compound statement is formed when two or more statements are connected. So it's sort of like a compound sentence. So when you're connecting two or more simple sentences, you get your compound sentence. Same thing with a compound statement. It's formed when you have two or more statements that are connected. So we have conjunctions and disjunctions. Conjunctions and disjunctions. So conjunctions, these are compound statements and these use the word and. So that's a key thing with conjunctions. They use the word and to connect our simple statements. So the example, alright, if sentence P, we have today is Tuesday. In sentence Q, today there's a softball game after school. So our conjunction, P and Q, today is Tuesday and today there's a softball game after school. Now conjunctions are true, this IFF, this is your if and only if. So these are true if and only if both statements are true. So if one of those statements is false, the entire thing is false. So, but if they're both true, then it's true. So with the and, they both have to be true. Now we have this thing called a truth table, where we have our P and we have our Q. Now T stands for true, F stands for false. So P can be true and Q can be true, or P can be true, Q can be false, or P can be false, Q can be true, or P can be false and Q can be false. So this is called a truth table. Now, what we look at is P and Q. Well, with that and, they both have to be true. So P has to be true, like today is Tuesday, and Q has to be true, there's a softball game after school. Well, if today is Tuesday and there's a softball game, that means this statement is true because it uses the word and. Well, if today is Tuesday, but there's not a softball game, well, P is true and Q is false, that makes this entire thing false. Well, if P is false, it's not Tuesday, but there's a softball game, well, the statement's still false because they both have to be true. And then same thing, if P is false and Q is false, well, since they're both false, neither one happens, so the entire thing is false. So for and, both P and Q both have to be true statements. If we look at the next one, disjunctions. Now, these are compound sentences that use or. So these use or to connect to simple statements. So Miss B likes pizza and Miss B has blue hair. Our conjunction, Miss B likes pizza or Miss B has blue hair. Now there's two types of disjunctions. There's the exclusive one, which is the what you hear every day. Like you're at a restaurant, you can have soup or salad, or you can do this or you can do that. So they are the exclusive because you have to choose one of them. But in here we have inclusive where it can be one or it can be the other, or we can actually have both. So you're not going to go to a restaurant and they're going to ask you, do you want soup or salad? And you say both. So that's why in here it's called inclusive, where we can actually have both of these be true. So we need one, either P or Q to be true so that we can actually do something. So if P is true and Q is true, or means they're both true. Well, if P is true, F or Q is false, well the statement's still true because Ms. B does like pizza, that's true. Well, P is false, but Q is true. Well, Miss B has blue hair. One or the other, it's still true. If if P is false, so she doesn't like pizza. Q is false, she doesn't have blue hair. Well, Miss B likes pizza or Miss B has blue hair. That's false because she doesn't like pizza or she doesn't have blue hair. And now negations. Consider this following statement. It is raining. It is not raining. The second statement is the negation of the first statement. The notation for the first statement is simply P. It's raining. The notation for the second one is not P. That's our negation, so it's not P. So if we have P is true and false, not P, well, the opposite of true is false. If we negate a false statement, it becomes a true statement. So now we have a law to explore, De Morgan's law exploration. So now when we look at this, our truth table here, it says complete the truth table for the negation of a conjunction. And notice the fourth column is a negation of the third column. Now, watch what happens with this and. So we need P and Q to both be true. So P and Q have to both be true. So if we look at P, true, true, and that's true. Well, true, well, false, that means this is false. False and true, that means this is false. And they have to both be true. Well, false and false, that's still false. Now this says negate P and Q. So we are going to negate every single thing in this column. So what happens here is true becomes false, false becomes true, false becomes true, and false becomes true. So we negated everything in this column. Now when we look at the next one, it says complete the truth table for a disjunction. Now, if you notice, it says not P. So we are going to go back to this one, and we want to negate P. So true becomes false. True becomes false. False now becomes true. False becomes true. So we negated everything in this entire column and made them true to false, false to true, false to true. And now the next one says negate Q. So now we're going to look at Q. Well, true becomes false. False becomes true. True becomes false. False becomes true because we negated everything in this column. Now the next column here says if we have not P or, so not Q. So or means one or the other has to be true. They can both be true or one or the other. So when we look at this first one, false and false. Both statements are false. So the or, that's still going to be false. Well, we have a false statement and a true statement. Well, the true statement will say that or, well, this can be true because we have one true statement. Well, true statement and a false, well, once again, we have that one true. So our entire thing can be true. And then true and true, so we have two true statements. So we have another true. So P, not P or not Q, we have false, true, true, true. Now if you compare these two last columns, so if you compare these two columns here, so if we compare these, what do we notice? What do we see, what's our observation? Well, they're the same. The last columns are the same. So when two logical statements have the same truth value, they're said to be truth functionally equivalent. Alright, so if we negate P and Q, our truth functionally equivalent to that is not P or not Q. So it's not P or not Q. Now if we look at the last part, writing some of these sentences, well, Q and R, well, Q is Christian swallowed a bug in PE. So Christian swallowed a bug in PE, and S or R, Sayajun is standing on her head. If not P or S, well, not P means Vanessa doesn't have an A in class. Not a surprise. Does not have an A in class, or S, Lucas runs cross country. So one of them has to be true. They can both be true, but one of them has to be true since it's an or. And means they both have to be true. Now when we look at this next one, it has this little, we're negating this entire thing. So what we can say is that it is not true that Christian swallowed a bug. So Christian swallowed a bug, or Lucas runs cross country. So that's not true. So we're saying it's not true that Christian swallowed a bug or Lucas runs cross country. P and R or Q. So P, Vanessa has an A. So Vanessa has an A. And either R or Q, Jayoon is standing on her head, or Q, Christian swallowed a bug. And then S and R, or not P. Well, S, Lucas runs cross country. So Lucas runs cross country. Lucas runs cross country. And is standing on her head. Or Vanessa doesn't have an A. Have an A. Not P. Vanessa has an A, so not P. Vanessa does not have an A. And that is our little exploration with and, or, and not in logic.